I'm Runshan. I'm a PhD student at Heinz College, and it's my great pleasure to share with you our project on potential disparate impact of algorithms in housing market. I heard some. Is that my noise or something? Okay, I'll just go ahead and start. So if you have, if you're interested in housing market or have ever thought about buying or selling a property, then you probably heard about this website called Zillow. Zillow is basically an online real estate database where you can find detailed information about properties. And what's interesting about Zillow is that ever since it was founded in 2006, it published this home value estimate for like over 90% of the properties in the United States. And this estimate are called Zestimate, and they are produced by Zillow's algorithm that aim to predict property sales price. So now if you want to know how much your property is worth, you don't have to go to an agent or appraiser and wait for several days. You can just go to Zillow and find the Zestimate of your property instantly. So news articles and informal chats with people working in housing industry suggest that now many people take Zestimate into consideration when evaluate properties. And this makes us curious, how does Zestimate affect housing market? Specifically, would it affect the decision to list the property on the market? And how would it affect the ultimate market outcome, which may include the sales price or like the time on market, like the time that needed to sell the property? And perhaps more importantly, are those impacts different across different neighborhoods, and therefore could lead to disparate impact across different demographic groups? So to answer those questions, we built a structural model to capture the key dynamics in housing market. So for the buyer side, we model the buyer's evaluation of a property as the weighted average of Zestimate and information from other channels, which we call like intrinsic values. And the buyer's offer would be a function of buyer's evaluation and the listing price. And on the seller side, we assume that sellers know the offer generating process and optimally make decisions on whether to list the property or not, the listing price, and whether to accept an offer, move to the next period, or withdraw the property. So with the econometric model, we estimate the model use property level data on about 250K properties in Pittsburgh. And with the estimated model, we can run like simulations about the counterfactual market outcome in a world where Zestimate is not available, and compare the outcome with the actual world where the Zestimate is present. And what we find is that compared to the case of no Zestimate, higher Zestimate would lead to a higher expected relative sales price, which means that for properties with higher Zestimate, the expected sales price is about 1.06 times the intrinsic value, whereas when the Zestimate is not available, the expected sales price is only like 0.96 times the intrinsic value. And we also find that higher Zestimate will lead to longer expected time on market, but still higher present value of sales overall. And because higher Zestimate would lead to better market outcome overall, so it would also lead to higher probability of enter the market, meaning that properties with higher Zestimate are more likely to be on the market. And perhaps more importantly, what we find that Zestimate may create disparate impact across different neighborhoods. So first, we find that Zestimate have different accuracy level across different neighborhoods. And in this box plot, you can see that the mean absolute percentage error of Zestimate is higher in more Black concentrated neighborhoods. And the cause of this accuracy gap, like there might be many causes, but we're curious, like how does this accuracy gap affected the final outcomes? What are the implications of this accuracy gap? And we find that we already know overvalued properties are more likely to be listed on the market, And as a result, the market may be filled with these proportionally more overvalued properties. And in the poor neighborhood, in the Black concentrated neighborhood, the Zestimate is less accurate, and therefore the entry decision might be affected more by the Zestimate. And as a result, this unbalance might be more serious. So in other words, even though the Zestimate itself is not biased, it could still promote inequality in such a way. So here we want to highlight that when examining the disparate impact of algorithms, it's also very important to think about the interactions of the output of the algorithms and the market dynamics. So that's all I have for today. Please let me know if you have any questions or comments.